All right, so for today, we will start preparing or continue preparing for our final exam. Today's topic is going to be Unit 2. So let's flip to page 5 in our packet. There's not that many questions in today's review, so we should be able to finish this very quickly. I also have my word wall ready to go. And of course, I'm going to open it to Unit 2 in case there's anything I need to add to it. So here we go. What is the quadratic formula? Well, remember, quadratic formulas only work for quadratics. That's the first thing. So the quadratic formula, as we mentioned, it is only for quadratics. So it's only for quadratics. Remember, it's got to have that power of 2. If not, we're not allowed to use this formula. And of course, the other thing that we want to mention for this is you have to be given an equation if you're going to use a quadratic formula. And that equation takes this form: ax squared plus bx plus c. But here's the most important thing. Before you use the quadratic formula, the one thing you have to be careful with is it must equal 0. So it must equal 0. All right, now remember, the main thing now is we're going to have an a value, a b value, a c value. We're going to use numbers, not letters. And so here is the quadratic formula. Again, it's in your word wall for unit number 2. Here we go. This is used to solve quadratics, as we already said. But here it is, the quadratic formula. Just remember, for every letter that you see, you should have an empty parentheses because it is a formula, and we use formulas for one thing, and that's to plug numbers into them. So I'm going to write it out here. Here is the official quadratic formula based on our word wall, and it says x equals. So that's the very first thing you should be writing down. X equals, because we are solving, remember, we are finding x-intercepts, zeros, whatever you want to call it, roots, of course. So it's negative b plus or minus the square root. These are all the things you can't leave out. B squared minus 4ac. Notice I keep saying letters, but I'm not writing them down because the idea is all divided by 2a, because the idea is every letter should be a number that you plug in. But of course, right now, this is just the formula. So this is your b value twice, your a value above and below, and then the c value is the only one that's used once in the formula. But that's the idea. We plug this in to our quadratic formula, and then the calculator, our Desmos calculator, kind of takes over right after that. In fact, you know what? Let's practice right away. So it says, what are the solutions of the equation? Now, a couple things. One, it already equals 0. That's good. And it has a power of 2. That is the other thing we want to make sure. Remember, quadratic formula only works for quadratics. So we do have everything we need. Now, normally there's 2 ways of solving this type of equation. Number 1, we can do factoring. But if factoring fails, and we can check this one, let's see. Would it even be possible to factor? I would put an n here. I would put an n here. What multiplies to give you a 2? Well, 2 and 1. But will these numbers subtract to give us a 5? Yeah, you see, that's impossible. So that's how we know factoring just doesn't work for us on this one. But that's why we have the quadratic formula. Technically, the quadratic formula does work for each one of these problems. And so when we're setting up the quadratic formula, remember, when we did it in class, I actually like doing the discriminant first, which is the inside of the square root. We like to take care of that. So the discriminant, which is the part that says b squared minus 4ac. Again, that's the inside of the square root. Now, remember, that gave us some special information. So let's see. Let me get this formula ready. B squared minus 4ac. Again, it's a formula. You leave blanks. And now we need the b value. Well, the b value is the number 5. Says we need an a value. Well, remember, it's not the n. It's what's in front, so it's just the 1. And then, of course, the c value. Now, remember, the c value does include the negative, so negative 2. And then again, we let Desmos help us out with that here if we need it. So we work this problem out, and according to Desmos, all of this ends up being the number 33. Now, remember, the discriminant is telling you a couple things. The main thing it tells us is because it's positive, right? We have a positive number. Well, then it just means we're going to have 2 real x-intercepts or solutions or roots, whatever you want to call it. So now I know I am definitely going to get 2 answers for this. But now that I know my discriminant, the inside part, well, now I can actually go and use it towards my quadratic formula. So when we did it in class, we like doing it in 2 parts. So we have the quadratic formula here. I'm just going to write form for short. But now I can shorten it up. So here's my quadratic from earlier. X equals negative parentheses plus minus. Now I'm going to make my square root really short. I know it's long there, but that's because we already did the work for it, with a big fraction all over 2a. So we need a b value according to the word wall here. My b value was a 5, so I'll put my 5 in there. What we put inside was this. Remember, we already did the work. This is my discriminant. My answer was 33. Well, then I'll throw a 33 in there. And then at the bottom, it needs the a. Well, the a we already said is a 1, so we'll throw our 1 in there. And now we're just going to work out what we can. A negative times a positive is a negative 5, plus or minus. Now, the square root of 33. Normally, we would ask ourselves, well, can I take the square root of that? The answer is no. But can I break up a 33 into 2 numbers? Well, nothing really divides 33 except 3 and 11, and those aren't perfect squares. So trying to break it up just doesn't work. Well, then I get to leave it alone. So I'm going to leave it as the square root of 33. And then at the bottom, 2 times 1 is just a 2. And there it is. Those are my 2 real roots. One of them is with a plus. The other one is with the minus. Now, they didn't ask us to round off, so they do not want us to use a calculator in this problem. They just want me to leave it alone. But just like that, these are technically 2 answers because of the plus and minus. All right, so that's the first big idea in unit number 2, solving with the quadratic formula. So let's move on to number 3. Let's see what number 3 is talking about here. Number 3 says, well, how do you find the vertex of, and again, it's got a power of 2. So because it has a power of 2, one of the first things we need to remember is that this is now officially a quadratic. And if I'm visualizing a quadratic, then we know the graph is a parabola. And so it's my goal to find that vertex. And just remember, the vertex is a point called x and y. And so we have to figure out a way, looking at this equation, for me to find the vertex without actually having to fully draw the quadratic. Well, remember, there is a way of doing this. And number 1, the first thing we do is we're going to find the x of my vertex. And we do have a formula for it. The formula that we talked about in class, and yes, it's in the word wall. In fact, let me show you where you can find it in the word wall here. In unit 2, let's see, where are you? There it is. This is standard form, A, B, C. Look at that, A, B, C, A, B, C. So it's this one. It says the axis of symmetry should be the first thing. There's the formula. X is equal to negative b over 2a. That's what I need. So x is equal to negative b over 2a. So I am going to plug in. So that's the first thing. And as soon as I get that, well, that's my x. Well, then the next question is, all right, well, you found your x. So how do you find the y value that belongs to that x? Well, like we always do. If you already know the answer to one of your problems, then the second step is find the letter y. Find your y value of that vertex. And all we have to do is remember that if I'm going to find the y value, all I have to do is plug in the x that you just found up here, plug in that x into the original, I'm just going to write OG equation. And then simplify. Remember, I'm not technically solving. The calculator is going to do most of the work. But whatever I get from here, that will give me the answer for my y, for that vertex. But it's really just plugging in. That's the main thing we need to remember. As soon as you have a number for a letter, you plug it in. Well, that's how you get the other number that you're looking for. So once again, we're going to do a little bit of a practice here, a little practice for us. So example number 4, let's see if we can keep it all together in one screen so we can see what we talked about and how we use it. All right, so idea number 1, how do we find the vertex? So here I have my A value. My A value is a 1. My B value is that -6, not the X, just the -6. And the C value is the letters -1. Sorry, it's the number -1. Now, we want a vertex. In fact, I could already start getting it ready. Here is my answer. The vertex is the point blank and blank. So we still need to find it. All right, but I have a spot ready where I'm going to start putting my numbers as we go. So the first thing I want to do is I want to find the X value. So it says X is equal to negative blank over 2 blank. Again, I'm using that formula that we just wrote up here. And I only need the B value and the A. We don't need the C, that's fine. We're only using this one. So my B value is -6. My A value is that invisible 1. Now it's time to just get to work. Negative times a negative is positive. 2 times 1 is just 2. 6 divided by 2 is 3. And there we go. We found our X value. Now, if it's a multiple choice test, I would start striking out any of the answers that don't start with a 3. But I do need to find the Y value that belongs to this. Well, remember, you have an equation called f of x. We have this equation that'll help me find the Y value. So in fact, you know what? I'm going to copy that equation down. It says Y equals, instead of f of x, I'll just write Y, x squared minus 6x minus 1. Now, as you heard me say it, I said the letter x, but we never wrote it down. Because remember, the one thing I'm going to do is, this is the x. Well, then that's what I'm going to plug in. I'm going to put a 3 in here and a 3 in here. And of course, I could do it individually, or I can let Desmos handle the rest of this work for me. But if I let Desmos do the work, Desmos is going to tell me that my Y value is -10. And so just like that, we have our vertex. Again, I already had a spot ready for my answer so that as I did my problem, I had a place to put my results. But there's the X and there's the Y value of my vertex. Again, it's a small process, but you do need that formula. You're going to need it, so make sure you highlight it somewhere in your word wall. Now, you do have 2 U-try problems, but before you do that, we're just going to finish the note because from what I remember, yep, we only have one more thing to do. So flip the page. Here's the last problem in our Unit 2 review. Remember that last question is an honors question. This is for the CP course, so we're only going to cover number 7 right now, but this is it. So we're going to remind you about imaginary numbers. Now, imaginary numbers obviously use the letter I. So you see, you have 2 examples of imaginary numbers because they have that I in them. But the one thing to remember about it was this. Remember that I squared is equal to, well, think about it for a moment. And you should already know it's in your word wall somewhere. In fact, I'm going to show you where. Imaginary numbers. See, here we go. I squared is equal to -1. So if I squared is equal to -1, well, let's write it in. It's equal to -1, which means that as soon as I see an I squared anywhere written out, it should be replaced with -1. In fact, we have a little brief example here. Remember, you're going to multiply the way you've always multiplied in math in all of your algebra classes. It says 3i times 2i. Well, first of all, 3 times 2 is 6. I times I would be I squared. But again, this is what this note is trying to tell you. As soon as you see an I squared, there's the 6, but I am not going to write I squared again. That I squared needs to be changed to what we said earlier, to a -1. We should never see an I squared in math because it can easily be turned into a -1. Well, now you need to actually multiply it. 6 times -1 is just -6. And so just like that, there would be the solution to this quick little example. But again, anytime you see I squared, you kind of have to get rid of it right away. Always turn it into a -1, and we should never see I squared again. So This is what the question is going to look like on the test. Now, you might read this and people say, yeah, but what do I do with it? Well, don't get hung up on the a plus bi. They said, which expression is equivalent to the product of the two complex numbers 3 minus 3i and 1 minus 6i in the form a plus bi? Are they using a lot of terminology to try to throw you off? Of course. But as we studied and prepared for the SBAC, one of the things we said was learn to pull the math. This is math. That looks mathematical. And I could write them both down and then figure out what I do with them. Let's see, 3 minus 3i. There's 1 minus 6i. But there was a clue here that they gave us that tells me exactly what they want me to do with it. And that's right. And that's here. The word product. The word product is a word that you've been seeing since your elementary days. And when we see the word product, all they're telling me to do is to multiply. That's why we keep the math as simple as possible in this class. As soon as we see that word and they said multiply, well, let's use that old school dot right in the center. That represents multiplication. So there, we don't worry about anything else. If you're concentrating on the a plus bi, well, that's the problem. Concentrate on the math that was discussed or brought up. So we've done these plenty of times. This is a binomial and a binomial. So a 2 by 2, which means I'm going to multiply 4 times. So here we go. Just like you've done in Algebra 1, 3 times 1 is 3. 3 times negative 6i is negative 18i because it's just classic multiplication. But now I'm going to multiply 2 more times. But now it's with negative 3. So it's negative 3i times 1. Oh, negative 3i, you're just multiplying by 1. Don't ever think that. All right, negative 3i times negative 6i. Well, first of all, negative 3 times negative 6 is positive 18. But I times I would be I squared. And yes, will I change that to a negative 1? Well, yeah, that's coming up. Because that is the one thing we need to remember. This is the only one that's going to go through a little transformation that's going to change on us. Well, let's continue the problem. So first things first, there's a 3. We always combine like terms. I want to stick to what we've done for years now. And negative 18 and negative 3 would be negative 21i. And then here it comes. That 18i squared, remember, yes, it says plus 18. But we already know I squared should never stay like that. I squared needs to become negative 1. That's what we change it to. And now that we wrote it, well, then let's actually finish the problem. Now, you could have probably done it before, but 3 minus 21i, negative times a positive is negative 18. All right, so then the only thing I can combine here is the 3 and the negative 18. Remember, this is now untouchable. That negative 21i, there is nothing that can combine with that, so that's done. There's the imaginary component. And then, of course, 3 minus 18, well, that's negative 15. But remember, the real component always goes in the front. So the real part is always in front. The imaginary component is always in the back. Not that it matters because we were already done with the problem. And so this was the answer right here. All right, once again, you do not have to worry about number 18 or number 10. So you really only have 3 problems that you need to do just like these in your you do part of this assignment. So your classwork is only 3 questions. You should have plenty of time to get those 3 questions done before the end of the block. With that said, have a wonderful day, and I'll see you next time.